Yeah, hello everyone. My name is Arelum, and I'm going to present about effective tests. I hope some of you already creating a unit test to cover the code itself. Some of you create end-to-end tests, and sometimes end-to-end tests are, to be honest, pretty interesting, engaging, and sometimes we create more than needed, to be honest. And we kind of forget about integration tests at all. So, yeah, let's go further. OK, so basically, we've already seen the testing pyramid at least once, but we might forget what it was all about. So let me briefly just explain what the layers are and what they do. So the bottom layer we call unit tests. Unit tests actually test a unit in isolation from its dependencies. So basically, you have one component that you test, and all the things that it interacts with would be mocked, or you just test the one component itself. So as you can see from this pyramid, we can see that it should be like a huge amount of unit tests should be created compared to other layers. So the next layer would be integration tests. So integration tests are testing a couple of components together, like real components, more than two. And they are more narrower scope compared to end-to-end tests. And compared to end-to-end tests, there's no need to have a working whole system properly. So we can just test if those two components are communicating properly, sending one message to execute some kind of action to another component. If the another component received and the take action, process it, then like those two things works properly for sure. So the next one, the one that I like the most is end-to-end test, because I write them like maybe daily, because they're really engaging, interesting, but as you can see, they should be pretty, a small amount of end-to-end tests should be created for cover whole system. And basically, end-to-end test means that we're trying to simulate end-user behavior. So like, I'm going to a website, clicking on a button, then I should see some kind of image, or I don't know, like we test whole system. OK, so basically, as you can see, in unit, we test only one component, integration, 2, 3, and etc. components, end-to-end test, like a lot of components integrated with each other. So that means since we have more integration, it will take a lot of time to execute those tests. And as we know, time is money. That means it will be very costly to run end-to-end tests. And yeah, unit tests would be fast and cheap. And something in between that's pretty better than end-to-end tests is integration tests. So basically, this is kind of a theory part, which I wanted to make it more relatable to us, to understand, to test the simple oven. And for example, the oven will have a temperature knob, which would turn on the heating starting when you set temperature greater than 40 Celsius. And it goes up to 260. Other requirements could be for temperature knob that it like tick increment every 20 degrees, like it could be 40, 60, 80, 100, and etc. That's the requirements for temperature knob. Then we will have a mode knob, which would be, we'll have a grill mode, which will just turn on the heating unit inside the oven, and the fan. Bake would be just turning on the heating unit. So next one would be, OK, so basically, in order to find out when our food is ready, we need to have a timer. So the timer would turn on from 1 minute till 360. And the specific requirement for the timer would be that it starts to count down the time when it reaches set temperature by the temperature knob. Next one is a temperature indicator, which would be just turning on the red light when the heating is actively happening inside the oven. So that means if current temperature is lower than the set temperature, then temperature indicator is on. So the next one would be just inside components of oven. It's a fan. At the top and at the bottom, we have a heater and temperature sensor to measure the inner temperature of our oven, or we can call it a thermometer. Yeah, so basically the oven would look like this. And you might be wondering, why am I explaining the simple oven to you if the conference is about effective testing? But I just wanted to explain that we should really understand the requirements of our oven in order to come up with end-to-end test. So let's assume that our oven is a black box, and we know what we're going to put in, and we know what we expect from the oven. Like, we want to bake a frozen pizza. We know that at the output, we will have baked pizza, right? So basically, I was thinking what kind of user behavior, like user perspective scenarios, how the user is going to use our oven. So the first idea was to bake frozen pizza, grill meat with a grill mode option, bake meat with the lowest temperature and with the longest, bake meat with the highest temperature and shortest time. So changing temperature during cooking. And then we could set the timer only, but forget about the turning on the temperature. And yeah, it could happen, that power interruption. How would it recover after that? So those are end-to-end scenarios. But now, let's take only first one to specify, to go deeper, and create step-by-step end-to-end test for that. So basically, for bake the frozen pizza, we should have like 14 steps. Only 5 of them are just like an action that we take in order to get a pizza at the output. But 9 of those are just assertion. So as you can see, the code itself it's a pseudocode. Itself contains, like, it's pretty long. And for example, if the fan, I'm not sure where is it, yeah, I thought the oven fan starts automatically after the alarm stops. So if that one turned off, or something happened with it, it just broke somehow, then the whole test would fail. That means that for a tester, we should every time go to the Allure report or this report and find out where exactly it failed, and then go deeper which component specifically failed. And the maintenance job, the labor-intensive job, would take like 20 minutes per day or even more. So that means inefficient usage of our time. So what I'm suggesting is to take the third, for example, step, turn the temperature knob on the control panel to 200 degrees. Here we go. Yeah. So let's try to create integration tests for that. So if I turn the temperature knob to 200 degrees, it will be sent to control board. The control board would send it to heating unit to actively heat the oven. Like, this is in like schema how it would work. So we only test this pass with the help of integration test. And yeah. And there is no need to, like, the mode knob or timer knob doesn't have to consider it in this test at all. And you can see that this is like a pseudocode as well. So knob temp, set temperature to 25. We send this message to control board, then assert if the one that I received to control board is equal to the knob temperature. The same actually happening here as well. Control board and heating unit, the logic is the same. Heating unit just asserts if the one temperature that it received and the one that control board has are matches. And basically, you might assume, why did we split temp knob, control board, and heating unit? Because for integration test, I mentioned that we could test 2 or more components, but it would be really complex to test like a 3 components right test for that. That's why we just make it simpler and split it. But you can do it with the 3 components as well. So, yeah. OK. So now let's go deeper into the temperature knob itself. Let's try to test it in isolation. So in that case, we could understand the difference between those layers. So the unit test basically tests a temperature knob in isolation. You might assume that temperature knob is sending a message to control board, like in a previous example. But here, we have a mock control board, which means that it's like a fake thing. It's not a real thing. And we are just verifying it. The set temperature function triggers the call of control board, I think. Yeah, so basically for 200 degree that we set in temperature knob, I created a small like a test by given when then template. So given temperature is off, when set to 200 degrees, a third temperature function triggers. So I wanted to pretty better explain the difference between integration and unit. But the thing is, you see the set temperature function over here. And the set temperature function is inside temp knob. So that means it just triggers control board. And that's all. We don't have any logic inside this mock control board as we had before in integration test. I hope that kind of makes sense. And yeah. OK, so after that, what we could test? We could test boundaries, if it will send assertion, like call to the control board, and check if it will not send any set temperature function to control board if temperature is lower than 40. Oh my God, so unit test, we could just test it in isolation, the temperature knob itself. We don't need any kind of mocked components. So in that case, we could just test the ticking incrementation, as I said, 40, 60, 80, that we are incrementing it by 20 Celsius. Given initial state of temp knob is 0, and the current position is 0, then we turn the temperature knob clockwise one time, and then we assert if it was turned clockwise once. So here it goes, and that's all. Yeah. And the suggestion that one article suggests is to have more integration tests compared to end-to-end and unit tests, so that we would rely not on the whole system works, not on a system that it works properly, but mostly to find out easily which component specifically failed. And yeah, so never forget, it's good to automate all the tests, but we should not forget about user behavior, usability testing. So yeah, we should think about exploratory testing as well. So I think that's all for me.